Hey, folks. Week 12, we're closing in on the end of the trimester, so I want to just kind of give you a rough idea of what it is we're doing on week 12 next week if you happen to be missing school next week. Or if you just need a quick review if you're looking at this afterward. All right, so let's get started. If you remember last week, we asked people to kind of own these 6 big ideas. We now have a pretty good understanding of what a chemical formula is. In particular, you should just pretty much have memorized the chemical formulas for water, oxygen, carbon dioxide, and that great big scary one, glucose. This week, we'll kind of spend a little bit more time trying to understand what ATP is and how we get it. Remember, with photosynthesis, sunlight goes into the plant along with carbon dioxide and water, and oxygen comes out. Sugars from photosynthesis go into the plant itself. And eventually, as we'll find out today, when we eat plants or we eat something that eats plants, those sugars and all of their goodness ends up in us. This is the first diagram I've been able to find that actually shows that the sugars stay in the plant, which is really the case until the plant gets eaten. All right, let's jump right into cellular respiration, and we'll kind of tell you that it's the opposite of what photosynthesis is. Remember, photosynthesis, we took carbon dioxide and water and we made glucose and oxygen. If you look at the graphic down below, we're taking glucose and oxygen and producing carbon dioxide and water and this weird chemical called ATP. All right, this happens in the mitochondria. Photosynthesis takes place in the chloroplasts. All right, let's talk about that ATP and think of ATP as a chemical battery. And in the mitochondria, the energy from the glucose, all that energy that originated in the sun, that into the glucose goes into the mitochondria. The only thing that energy does really is to take, if you look in the graphic, the little p, the phosphate, and attach it. We go from 2 phosphates to 3, which is why ATP is adenosine triphosphate. You don't have to know that. Diphosphate is only 2, triphosphate is 3. Think of the triphosphate as having extra energy, much like a set mousetrap. You're real cautious if you're moving a mousetrap that's been set, but once it's been sprung, which is in our model here when there's only 2 phosphates, then it has no energy. ATP is little tiny batteries, little molecules that have energy that float all around your body through your blood. They power absolutely everything that you do. If you jump, skip, or if you're trying to stay awake while you're watching this video, all of that is powered by ATP. All right, and let me move this so that we can actually read the screen. So whether you're riding a bike uphill or downhill, whether you're just sitting in a chair or running a marathon, you need ATP. So that's where this clever little statement comes in. I think I use ATP. Well, really, it should be I think, therefore I use ATP, because thinking definitely uses ATP. Think about it. All right, putting this into a graphic, we've got glucose and oxygen coming in. They should look familiar, C6H12O6, and oxygen is O2. This time, instead of going into the chloroplast, they're going into a mitochondria. What comes out? Carbon dioxide, CO2, and water, plus the ATP molecule we just told you about. Got it? Good. Let's put it together with photosynthesis, because that's kind of where we're going with this. Photosynthesis, if you look here, produces the sugars, the glucose. That glucose finds its way into the mitochondria and all of your cells. And when it's done with it, it gives off carbon dioxide and water. But this little squiggly here is the ATP that it sends out to the rest of your body. Where does that energy originate from? That energy originates from the sun. We're going to focus today and this week on the energy coming from the sun and going in one direction. The molecules, on the other hand, are constantly being recycled. Those are the two big ideas we want to hit. We can see those pretty well here in this graphic. Start over on the green side, the chloroplast. You'll see carbon dioxide and water and energy coming in. And about every sixth time, you'll see a glucose molecule right there shoot over to the mitochondria. The mitochondria then converts it into ATP, the little starbursts that are heading out. And you'll also notice that there's some water and carbon dioxide being given off. If you follow the carbon dioxide, it's just doing a loop. It cycles. But if you follow the energy, it starts on the left-hand side or the right-hand side of your screen and never comes back. Energy never returns to the sun. Matter cycles, energy flows. If you remember nothing else about this week, matter cycles, energy flows. That is the most important idea this week. Got it? All right. Let's see if I can do this. There we go. The idea that matter can't be created or destroyed is called the law of conservation of mass. Some places, some websites will call it the law of conservation of matter. That's less common, but it means the same thing. Even Homer Simpson knows about the conservation of mass because he's a really smart person. All right. If you are gone on the first day that you're here, whether you're a cohort or a B cohort, this is what we're doing in class. And when you get to class, I will hand you this. But really what we're doing in class tomorrow and on Thursday is kind of comparing photosynthesis and respiration. If you follow along, photosynthesis takes place in the chloroplast, respiration in the mitochondria. Take a look at the next two boxes though. Water and carbon dioxide go into photosynthesis and glucose comes out, glucose and oxygen. It's the exact opposite here on the other side. Glucose and oxygen go into the mitochondria, water and carbon dioxide come out. In photosynthesis, the energy involved is light. It starts the process. In respiration, the energy involved is ATP and it ends the process. Then we're going to ask students to write the formulas for these four compounds, water, carbon dioxide, glucose, and oxygen. Pretty straightforward. And then just name the elements that are there. And then the fun part down below, give us examples of how you use it. So I use water to go water skiing, or I use carbon dioxide to make my soda pop bubble. I like glucose to make my cereal sweeter, and some of my best friends breathe oxygen. That and the questions on the other side is what we're doing in class tomorrow. If you happen to not be here, don't worry about it. I will hand it to you. More important that you understand it, right? Here are those two really big concepts I told you we needed to make sure we understood. Matter cycles and energy flows. What do I mean by that? In matter cycling, that's the law of conservation of mass. When we go from oxygen and glucose to carbon dioxide and water, we have the exact same number of molecules before and after. We didn't create anything. We didn't end anything. So the atoms that make up you, think about all the atoms that make up your body. About 100 years ago, they were somewhere else, but they were still there. They haven't been created or destroyed. They've just been assembled into you or me. We're all just a bunch of Legos, maybe. Energy, on the other hand, moves in one direction. It doesn't cycle, it flows. And almost all energy comes from the sun. We've got to be kind of careful because some energy comes from nuclear chain reactions, which is really what's happening in the sun also. Energy flows in only one direction. um, which means, of course, that you're solar powered. One model we might use to compare the two, if you like roller coasters, think about being on an endless roller coaster where it just goes around and around and around. That's matter cycling. If you're on a water slide down at the Dells, you go down the water slide, it's a one-shot deal. You never see, you can watch those water slides and you'll never see anyone slide back up. So the trip down is a one-way trip, and that's energy flow. Matter cycling just keeps on rolling along. So the second day we're here, we're going to use that idea, the idea of energy flow, to try to trace the energy flow from the food that you eat, or from the sun to the food that you eat. And here's some very simple diagrams that kind of lay the groundwork for that. Let's say you're having chicken. Well, the energy that you get from that chicken started in the sun, went to plants. Maybe the plant ate grasshoppers. My chickens love grasshoppers. And then you eat the chicken, or you eat the eggs from the chicken. Now, we've got the same thing in two versions. What the important thing of both of these is, at no point does energy from the child go back to the sun. It's not a cycle. It's a one-direction flow. All right. In class tomorrow, or on the second day, students will be putting a diagram together, not quite like this. Well, let's do this one first. Here's how energy gets into your hamburger. It all comes from the sun and goes to a plant. And notice there's arrows to the bun and the lettuce and the tomatoes. Those are all plants, so energy from the sun went directly to them. But the burger and the cheese are from cows, and so the cow had to first eat the plant. So it's all about how the energy gets to the hamburger, and from there to get to you, it goes in your mouth. Again, energy flows, matter cycles. That's the key here. So here is what students the second day are doing. If you are not here, relax, I'll probably learn how to do this. If you're not here, don't worry about it. Just try to understand it. The assignment is not going to be a burden for you. Just make sure you understand the idea. So on the second day, whether it's Tuesday or Friday, we're going to ask students to make a diagram to illustrate the energy flow that starts at the sun and ends with you doing your favorite activity, and along the way goes through plants and the chicken, and maybe a trip to Culver's for chicken tenders. Now, if you happen to be a vegetarian and you don't want to put a chicken in that diagram, your energy flow is going to be shorter. It's going to go from the sun to the plant to you. So you're going to have to, instead of having chicken eat the corn, you're going to have to eat the kale. I've heard some people can actually eat that stuff. All right. With that, actually, I do like kale. Don't tell anyone. With that, that's how we're going to end this week. And the whole goal this week is for you to stay safe and get healthy. There are 2 assignments that you can do online. They're pretty straightforward. You're going to watch a short video and answer 5 questions. There should be no trouble getting those done. And I really hope I get to see you back in class, and well, take care.